easy BTech. So now the next concept name is conditional distribution function. So the name of the topic is conditional distribution function. Conditional distribution function. As the name indicates, here we introduce conditional probability here. So we already know that the conditional probability P of A given B is equal to P of A intersection B, sorry, P of A intersection B divided by P of B. P of B. This is the conditional probability we already know. Now we are introducing this conditional probability into the distribution function. We already know the distribution function is represented by fx of x like this. Now we are introducing conditional probability. That means let us define an event an event A and our random variable is we already know x less than or equal to x less than or equal to x. Now the conditional probability is written like this: p of x less than or equal to x given the event A is called conditional probability and is represented by like this: fx of x given A. So the conditional probability fx of x given A is nothing but p of x less than or equal to x given A. So it is also written as fx of x given A is equal to, this is the numerator and this is the denominator. So we can write like this: p of, according to conditional probability, it will be written as p of x less than or equal to x intersection A divided by p of A. This is the formula to find out the conditional distribution function. Formula to find out the conditional distribution function. Okay, so like distribution function having properties. Here also you are having properties for conditional distribution function. So the properties, coming to the properties. The first one is we already know fx of minus infinity is equal to 1. We already know in our probability distribution function, fx of minus infinity is equal to 1. So in this case, fx of minus infinity given A or B is equal to 0. So you can take event as A or event as B like that. So fx of minus infinity given A is equal to 0. So this is the first property. Now moving on to the second property. We are moving on to the second property. So in the previous case, in your distribution function, we have fx of infinity is equal to 1. In the same way, fx of infinity given A is equal to 1. Fx of infinity given A is equal to 1. This is the second property. Now, what is the third property? The third property is 0 less than or equal to fx of x given A less than or equal to 1. This is the same as, so the basic difference you remember here is the only denominator part is adding here in in comparison with your distribution function. So in your distribution function you are having fx of minus infinity is equal to 0. Whereas in conditional probability distribution function it is having minus infinity given A, infinity given A, x given A. So wherever x is having, that is should be replaced with given A. That means if you remember like this, divided by A, like that also you can remember. So this is the third property. Now the fourth property is fx of x1 given A less than or equal to fx of x2 given A if x1 less than or equal to x2. If x1 less than or equal to x2. If you remove this equal to, sorry, here this one is also removed. So fx of x1 given a less than fx of x2 given a if x1 less than x2. If x1 less than x2. Now the fifth property is fx of x1 less than x less than x2 given b is equal to fx of x2 given b minus fx of x1 given b, or b or a. So here in this case I took a, no. So again I am changing this to b. Whatever it may be. If it is a, it is you should write as a. If it is taken b, it is written as a, a, a. So fx of x1 less than x less than x2 given a equal to fx of x2 given a minus fx of x1 given a. Now, sixth one. So this is the same. This property is the same as your previous distribution function property. Fx of x plus given b. Fx of x plus given a is equal to fx of x given. So conditional distribution function is also right continuous. Right continuous. So these are the six properties you are having in your conditional distribution function. So conditional distribution function. The first property is fx of minus infinity given a is equal to 0. Second property is fx of infinity given a equal to 1. The third property is 0 less than or equal to fx of x given a less than or equal to 1. That means conditional distribution function is always lies between 0 and 1. Similarly, fx of x1 given a less than fx of x2 given a if x1 less than x2. The fifth one is fx of x1 less than x2 whole given a equal to fx of x2 given a minus fx of x1 given a, upper number minus lower number, or upper distribution minus lower distribution. Means upper number is here x2 given a minus fx of x1 given a, and the final one, sixth one, is this is fx of x plus given a equal to fx of x given b. That means conditional distribution function is right continuous function. Right continuous function. This is what about conditional distribution function. So now the next concept is the continuation of conditional distribution function. So that is conditional density function. Conditional density function. Conditional density function. So we all know the relationship between distribution function and density function. So the distribution function is represented by like this: fx of x equal to dy dx of distribution function. This we already know. Here we already know conditional distribution function. In the same way we can find out the conditional distribution function density function, that is fx of x given some event b is equal to dy dx of fx of x given b. That is the definition is like this. So conditional distribution function, it is the conditional distribution function is conditional density function is derivative of conditional distribution. Conditional distribution. So this is the definition of conditional density function. Conditional density function. So if ever in the exams, if they ask you about write about the conditional density function, that means We have to write this definition. We have to write this definition. This definition. Okay. Now next one. So in the same way, you are having distribution. I mean, you are having. So in the same way, we can have the properties of properties of conditional distribution. Conditional density function. Properties. Properties. If you know the properties of density function, if you know the properties of density function, that is small fx of x, we can easily write the conditional density function properties. So the first property of conditional distribution function is fx of x given b is always greater than or equal to 0 for all values of x. For all values of for all x. For all x. This is the first property of conditional density function. So the second property is integral minus into infinity, fx of x given b dx is equal to 1. So that means the area under the conditional density curve, area under the conditional density curve is always equal to 1. Is always equal to 1. Now the third property is if you want to find out the conditional distribution function, that is fx of x given b, you have to take out the integral of what conditional density function. Conditional density function fx of x given b dx. X given b dx. Okay. Now the fourth one and the last one is fx of small fx of x1 less than x2, sorry, x1 less than capital X less than x2 given some event b. It can be written like this. It can be written like this. It is equal to it is equal to integral of x1 to x2, integral of x1 to x2 fx of x given b dx, x given b dx. So these are the four properties of conditional distribution function. The four properties are same as normal density function. The first one is always greater than or equal to 0. Second one is area under the density curve is equal to 1. Third one, conditional density distribution function can be find out by taking out the integral of conditional density function. And the fourth one is if you want to find out the conditional density over a range of values, that must be represented like this: integral x1 to x2 fx of x given b dx. So this is what about conditional distribution and conditional density functions. Conditional distribution and conditional density functions. So the next concept is types of random variable. So types of random variables. So based on distribution and density function. Based on distribution function and density function. So that is different. This is different. So we already know types of random variable like continuous random variable, discrete random variable, mixed random variable like that. So those are different and these are different. So the first one we are going to learn is Gaussian random variable. So is Gaussian random variable. Gaussian random variable. So a random variable is said to be a random variable x, a random variable x. Suppose I am assuming my random variable x. If it is said to be in the form of it, if it follows Gaussian distribution, then it can say that it is Gaussian random variable. So how can I say that it follows Gaussian distribution. So the random variable distribution density function. So fx of x, its density function must be like this. So see here, don't 2 pi sigma x square e power minus of x minus ax whole square by 2 sigma x square. So these functions should be remembered. So these are very important while doing the problems in the next chapters. So please try to remember all these expressions. So this is the density function of Gaussian random variable. So it is looks like this: fx of x equal to 1 by root 2 pi sigma x square, fx of x equal to root 2 pi sigma x square into e power minus of x minus ax whole square divided by sigma x square. Okay, now see, so if I want distribution function, what I will do? So we already know that distribution function can be find out by taking the integral of what density function. So I will take minus infinity to x fx of alpha d alpha. That means the conditional distribution, sorry, density function is equal to 1 by root 2 pi sigma x square into integral minus infinity to x x e power minus x minus ax e power minus alpha minus alpha minus ax whole square by 2 sigma x square into d alpha. So d alpha, this is the conditional, sorry, this is the distribution function of a Gaussian random variable. Now there are some unknowns in this Gaussian random variable. So what are they? Here one is sigma x. So where ax is called the mean value of Gaussian random variable, and sigma x square is called the variance. Sigma x square is called the variance. So the square root of variance is called always equal to standard deviation. Standard deviation. So these are the three. Okay, two. These are the two variables we have to remember. So ax and sigma x square. So ax means mean value. Sigma x square is the variance value. So the Gaussian random variable has a density function like this: fx of x equal to 1 by root 2 pi sigma x square into e power x minus ax whole square by 2 sigma x square. Similarly, the distribution can be found out by taking out the integral of density function, and it will be equal to 1 by root 2 pi sigma x square into minus into x e power minus alpha square. Alpha means alpha minus ax whole square by 2 sigma x square into d alpha. And the variables are ax is mean value, sigma x square is variance, and sigma x is the standard deviation. So if you want to plot the distribution function, I want to plot the distribution function. How is the plot? So the plot will be like this. So the plot will be like this. So it has the maximum value. It has the maximum value. At x equal to ax, at x equal to ax, ax, and that maximum value is equal to, its maximum value has, it is 1 by root 2 pi sigma x square. The maximum value is equal to root 2 pi sigma x square. So again I will going to write x, and this axis is fx of x, and it is having a max value at a equal to x equal to ax, and this is origin. And the max value is equal to 1 by root 2 pi sigma x square. This is the graph or figure. To whenever they gave you figure, you should find out. So by seeing this figure, you can say that the given random variable is in the form of Gaussian distribution or Gaussian density. Okay, so we can also say that the Gaussian density function is a symmetric function about x equal to ax. Why? Because if you fold here, the entire figure should be measured with half of the figure. That means both are same. I mean, you can call this one as even function. Even function. Okay, so the Gaussian density function is a even function. Similarly, if you plot the distribution curve, if you plot the distribution curve, it is like this. So distribution function is an increasing function which slowly increases and reaches up to a maximum value of 1. Why? Because fx of minus infinity is always equal to 1. So fx of x is a increasing function. This is x, this is 0. So this is the figure of Gaussian distribution function. Why? Because Gaussian distribution function has a maximum value of only. So these are the figures which are explaining the Gaussian distribution function. Gaussian distribution function. The next one is normalized Gaussian distribution. Next one is normalized Gaussian distribution. Normalized. So why the name normalized comes? Normalized Gaussian distribution. Normalized Gaussian random variable. So when the random variable is called normalized Gaussian random variable, if its mean is equal to 0, if its mean is equal to 0, and variance sigma x square is equal to 1, then the Gaussian random variable is called normalized Gaussian random variable. So in that case, how the Gaussian density function looks like is it becomes 1 by root 2 pi sigma x square. That means sigma x square is equal to 1 root 2 pi e power minus x minus ax. So x square divided by 2. So this is called the normalized Gaussian density function by applying by applying ax equal to 0 and sigma x square is equal to 1. So so in the exam, if they ask you what is normalized Gaussian random variable, you have to apply ax equal to 0 and sigma x square 1 to the basic Gaussian random variable function. Basic random variable function. Now coming to the properties. So basically there are two properties for Gaussian random variable. Properties. So first one, fx of minus x equal to 1 minus fx of x is the first property of Gaussian random variable. So fx of x equal to 1 minus fx of x. Now the second one is fx of x equal to fx of x minus ax divided by sigma x minus ax by sigma x. These are the two properties you have to remember while doing the while reading the Gaussian distribution function. So two properties, fx of minus x is equal to 1 minus fx of x. So you should remember the properties are in terms of Gaussian distribution function. And I wrote normalized one in terms of Gaussian density function. So capital fx of minus s equal to 1 minus fx of x, and capital fx of x equal to capital fx of x minus, this is x minus ax divided by sigma x. These are the two properties we should remember while reading the Gaussian density function or Gaussian function. Okay. Now the next random variable is the second random variable is uniform random variable. A very simple one and very important one. Uniform random variable. Uniform random variable. So a random variable x is said to be uniform random variable. Uniform random variable. If its density function is equal to 1 by b minus a. Its density function is equal to 1 by b minus a, where a less than or equal to x less than or equal to b and 0 otherwise. And 0 otherwise. So this is the Gaussian density, sorry, this is the uniform density function form. Uniform density function form. Similarly, the Gaussian, sorry, the uniform random variable is represented by capital Fx of x, capital Fx of x, and is equal to 0 for x less than 0, 0 for x less than 0, and x minus a by b minus a for a less than or equal to x less than or equal to b, 1 for x greater than b, 1 for x greater than b. So this is the two types of, and that means this is the two functions. One is Gaussian, one is the uniform, one is the probability density function, and one is probability distribution function. So this is small PDF. So small PDF, and other is it is capital PDF. That means probability distribution function and probability density function. Probability density function. So now moving on to the figures. Moving on to the figures. How the probability density function of uniform random variable can be drawn. So it can be drawn like this. So from the expression we can say that it is a value of 1 by b minus a from a to b. The value of 1 by b minus a from a to b. So this is the figure of uniform random variable. So from the density function formula, you can say that we already know that it is fx of x equal to 1 by b minus a. 1 by b minus a in the range of a to b. In the range of a to b. So the uh, height of the curve must be is equal to what? Must be equal to, or amplitude of the curve is equal to 1 by b minus c in the range of a to b, and 0 everywhere, and the and the figure can be drawn like this. Similarly, the distribution curve can be also drawn like this. So in between a to b, it has a ramp curve. From there onwards, the amplitude is equal to, its amplitude is equal to 1. Maximum amplitude is equal to 1. So in between A and B, you are having what? A ramp curve. Why? Because the function says x minus a by b minus a. So that is a linear function in the range of a to b. So this is the, so your distribution function goes like this. Starts at 0. At 0 it is having a value of 0. Till a it is having a value of 0. From a to b is a increasing function. It is slowly increasing. Afterwards, it is a constant line with a amplitude of 1. With a amplitude of 1. This is what about uniform random variable. Uniform random variable. So with this, I'll conclude this session. Now we'll discuss about the other type of random variables in the next session. Thank you. Thank you very much. I request all of you to please share, like, and subscribe the Easy BTech channel. Thank you.